In this presentation, I'll be talking about what homeostasis is. Homeostasis is the tendency to resist change in order to maintain a stable, relatively constant internal environment. The dynamic equilibrium is maintained through feedback systems, positive feedback loop and negative feedback loop. Stimulus produces a change in the variable that causes an imbalance. This change is detected by the sensors, which input information to the control center. The control center compares against the set point. Lastly, output information is sent to the effector, which makes adjustments to the variable to reach homeostasis. Negative feedback is a process that helps to stabilize a change in the physiological state of the body to maintain a steady and stable environment. Negative feedback is more common in homeostasis. However, positive feedback is just as important. The regulation of blood glucose levels is an example of negative feedback. When blood glucose level rises, beta cells in the pancreas release insulin into the blood. Liver takes up glucose and stores it as glycogen, causing blood glucose levels to decrease to normal levels. When blood glucose level drops, alpha cells in the pancreas release glucagon. Liver breaks down glycogen and releases glucose, causing blood glucose levels to increase to normal levels. Positive feedback is a process that moves further away from a steady state as it amplifies the response until an endpoint is reached. When the first cherry on the tree ripens, it produces a gas called ethylene. The other cherries also begin to ripen in the presence of this gas. Once ripe, these neighboring cherries also produce more ethylene until all the other cherries are ripened. Therefore, this is an example of a positive biological feedback loop. In conclusion, feedback loops are the process where a change to the system results in a signal which triggers a certain result. Hence, feedback loops are important as they allow organisms to maintain homeostasis.